Hey curious, this is Utsav Mandal and today we'll be talking about why does a moving charge creates magnetic field. We have already known that force vector equal to V vector cross V vector into Q, but today is the question that why there is the V vector in the first place. So it would be very spooky to tell that it's already there, and it's very inside linked with quantum mechanics and Einstein's special theory of relativity. So today in this video we're gonna find out how the special theory of relativity explains a charged body creating something sort of called as magnetic field around it. I find more, check it out. By taking a magnetic field created around a conductor passing charge I, which is explained by Maxwell's hand thumb rule. But why? Why does it happen in the first place? Magnetic field come from? Amazing question. Let's find it out. Albert Einstein, the genius, the scientist and the greatest scientist of all time, told that he explained the universe using his theories, and two of the most famous were general theory of relativity, and the most important for this one is the special theory of relativity. So it's the special theory of relativity that explains it in a way that could be understood, but it may not, someone may not find it a very logical. Let me explain. Imagine a car which is moving at a velocity very less than the speed of the light. Not enough length contraction would be seen, but imagine a car which is moving with some comparable speed with the speed of light. In this case, the velocity is comparable to c, so the length of the car which would be seen by a viewer would be much lesser than its original, and it would be varied by the gamma factor in the Einstein's theory of relativity, and this is what Einstein says about high speed bodies, which does not obey all those logics and the Newton's law, which we have been reading from a while from the basic middle school. So the length contraction is the same goes for the electrons and the protons in the conductor. A conductor contains positrons and the electrons. Positrons are the electrons which are moving in opposite of time, or you say positron is the direction of current, and moving positrons denote moving current, or the electrons which are moving opposite denote current in their way. So here we say that length contracts for a charged body which is moving in the direction of the conductor charge. The charge direction and the motion of the body of the charged body direction same, then the electrons are in a relatively more velocity, which concludes that the electron goes more length contraction from the frame of reference of the charge, which causes it from the frame of reference of the charge to contract, and very many of electrons get contracted and takes lesser space, so the charge amount, the negative charge amount in the conductor from that referential frame of reference is more and is negative than the positive charge contained in the conductor, and that's why the positive and negative attraction happens, and the charged body moving in the direction of the current experiences attraction force towards the conductor. So we can say that magnetic field is an amended form of electric field. Same goes for the repulsion. That is, when a body is moving in the opposite direction of the direction of current, then what takes place? So it is explained that how a current carrying conductor causes magnetic field. So up to then we can say it's fine that special theory of relativity explains everything about current carrying conductor having some current, having potential difference, showing magnetic property. But then we ask, wait, what for the permanent magnets? Well, if you want to know about the permanent magnets, then check the link in the description to know about the permanent magnet. Stay curious, make the curiosity alive. Thank you.